So it's one thing you really had to do by yourself at home. And I only made you do evens. And I only put it in the 30. And it's only worth 14 points. But saying all that, Mason only has 3 homework grades, a participation grade, and now this study guide grade. So if he never turned in his coloring page, which is too little to it. I know, B. I'm just using you.
Oh, my bad.
So if he never turned in his coloring page, he didn't do those homeworks, and now he did get participation points because everyone got some sort, depending on your group last week. And now he's not turned in that study guide. You can see how it could already be at a bad start. So make sure you turn in your study guide. If you want to turn it in now because it's on your brain, that's fine. If you want to save it till the end of class, that's fine too. Doesn't matter. Doesn't matter. Okay, we are super behind on something. Someone tell me what we are behind on.
Workshops.
Have a great one. If you look at the date of the one on the screen, I'm still on the 10-2 to 10-6. Do you still have your 10-2 to 10-6? Which is really sad and scary. Today's 10-17. According to my notes, we never finished 10-2 to 10-6. I don't think we did 8, 9, 10. So we're going to do 8, 9, and 10 today. Tomorrow we're going to get super caught up. Now I already got like 3 in the room playing on the phone. Bless their hearts when I tell them this. So you're going to have to be self-motivated to get your own math done. Because I'm going to be here to mother you. So you got to get your math done. So I'm telling you in advance. You picked up the new workshop on your way in the room. Tomorrow I'm going over 8 through 13. 8 through 13. So I'm going over a lot. We got to start doing like a chunk of them, or else we're never going to get back on track. Because again, today's date is 10-17, and I'm wanting to work workshop from 10-2 to 10-6. So that is just sad. Okay. So we got to double up on our math workshops for a couple days until we get back on track. Not a big deal. Just got to double up. Okay. Other things to say. DJ was on it, and he can get a point for that. He was trying to go ahead and finish his test. Everyone's going to get a chance to finish their test. We don't have that many notes today. So at the end of class, that's what's supposed to happen. We do not. So if we can get through 8, 9, and 10 in our notes quickly, you can have the rest of the class for your test. I am going to leave the test with the sub, so if you came during 0 period to finish, you could. But again, I'm not going to be here to answer your questions or whatever, so it would honestly be best if you just wrap it on up today. Okay. Number 8. Let me zoom in. Number 8. What's the first thing I'm supposed to do on number 8? Number 8. What's the first thing I'm supposed to do on number 8? Yes, dear. You can get your point for that. I heard you say combine first. You can have it, table 5. Yeah, we're going to combine those like terms. We actually have like terms. Now, normally if it's 4, I would be like Abby Grace and think grouping. But since these two are alike, it's x squared plus 6x plus 8. Now, I'm out of room, so we're going to cut straight to the answer. I need to know my factors. 2 things that add to give me 6, multiply to give me 4. 4 and 2, table 3, get a point. X plus 2, x plus 4. 4 plus 2 is 6. 4 times 2 is 8, so it's x plus 4, x plus 2. Are there any questions about number 8? Number 9, what are we going to do first? Who said it? Dre, I thought it was you. You can take out the GCF. And at the GCF for this one is 3PQ. What would you have left? Two and 5 get a point. Okay, that's number 9. Are there any questions on number 9? Number 10 has 4 terms, so Abby Grace is right, and we are going to do grouping. When we do grouping, what am I going to pull out of my first group? Was that 5? I know it was 2. Who was the other group? Yeah, it was you, Drea? Okay. So 2 and 4 then, sorry. So 2x, and you're left with a 5x minus 7. And then with the other group, what do I pull out? And I'm happy because, again, I'm left with a 5x minus 7. I love it when the 2 insides match. That means I've done grouping correctly. If they don't and you have a sign error because you only pulled out a positive 3, you would need to go back and pull out a -3. Because if they don't match, you've technically not done grouping. So my final answer is
2x minus 3 and 5x.
thank you. Abby Grace, get another point. Okay, so again, factoring, so much fun. Someone asked me, like, hey, Miss Condon, when are we actually going to do something with the factoring? And we're so close. We're still just practicing factoring, and I swear eventually we're going to apply it and get answers and make it useful. But I get for now, it's like, yay, we're done. It still looks a hot mess. Let's see what got. Yes, dear.
Question, can you give a real-world example of when we'll have to use factoring?
Yes. Do you really want me to? No. Anytime a quadratic happens with like travel over, which happens anytime you throw something that comes back down to the ground. Anytime with that, we're trying to figure out like when the initial happened and when it hits the ground again. Those two answers might represent those two things. No, I'm done. I told you didn't want me to. So factoring has to do with quadratics. Quadratics happen anytime we involve gravity. Okay. Okay, so I forgot to pass this out at the beginning. New unit means new notes. So we just tested on the first half of chapter 3, and now for the second half of chapter 3, which in my personal opinion is the easier half.
Yay.
Yay. Okay, and you're not even going to hurt my feelings. Yes, dear.
We can do that one.
Okay, I know it didn't count somewhere. Raise your hand, and you're not going to hurt my feelings. Okay. Do not feel peer pressured into. You do not have to raise your hands. It doesn't make a difference to me. I know how you feel already.
Good. I'll try to give him a straight.
Okay, so it's like a take point work or nah? I'm going to let it go. Okay. Raise your hand if you super duper don't raise it because you didn't love it. Raise your hand if you just love the problems with 3 equations and 3 unknowns. You just thought that was the best thing ever.
What do you mean?
Okay, you enjoyed solving the 3 equations with the 3 unknowns. I got a couple. Raise your hand if the 2 challenge problems, the 4 equations with the 4 unknowns and the 5 equations with the 5 unknowns. Those were the best.
I got it. I got to look at them. I don't like enjoy it.
Okay, if you didn't really enjoy those at all, and you thought those were 1, very time consuming, 2, very tedious, and 3, there must be an easier way, you're completely correct. There is an easier way. Now, is there potential that the teacher is going to ask you again to show using elimination and all this? Yes. And if you enjoyed it, I highly recommend in college a class called Differential Equations because we did a lot of that in there. It was the best. But from here on out, we're going to find out that there is a faster, better, easier way. And of course, you're not surprised. It involves using this. So we're not going to get to exactly how to, if you don't have a calculator, you don't need it today. You don't have to have it today. It's going to be Thursday's problem. But starting at the end of this week, we're going to learn how to put matrices, that's what we're about to talk about, in the calculator and make the calculator solve a problem like that for us. So DJ, unless I ask him specifically to solve it by elimination again, he never has to, again, from here on out, use his calculator. So if he were ever to see, let's say, a 3 equation, 3 unknown on the ACT, for instance, please, because you love life and you're trying to get a good score, you're not going to take all day. You don't have enough time to solve it out by hand. You're going to put it in the calculator and make the calculator work its magic. So today we're going to learn about how life can be so much easier if we just learn to love matrices. Okay, before we go on our matrix rant, we talked about we're behind with math workshops. Do you remember how last 9 weeks we had a perfect squares test? Yes. Well, no time in the near future. I'm talking like 3 weeks away out. But just so you know, there is a perfect cubes test coming. 1 through 10 only. So you have to know, for instance, 2 cubed is 8, 3 cubed is 27. These are things you're supposed to know fast. It makes your life easier. Again, we're just trying to help you overall in life. The faster you can do things on the ACT, the sooner you can move on to a more difficult question. Knowing your first 10 perfect cubes is going to help. So, you know, and then DJ's like, oh, I'll just memorize in order. 1, 8, 27, 64. I wouldn't do that if I were you. I print off all my stuff at once. When I went ahead and printed off that perfect cubes test, which is coming like 3 weeks from now, when I went ahead and printed it off, we put them in different orders. Like 2 cubed might be at the end. So knowing that the second one's 8 does not help. You actually have to know 2 cubed is 8. So just FYI. It's coming, so you know. So if you were ever, I don't know, bored, you could study that. Okay, so we are going to start talking about matrices. Our first two learning targets we're going to tackle today. First thing, we're going to state dimensions of a matrix. Before we can even do anything with a matrix, we need to know what a matrix is. And I'm not talking about the movie. So our very first blank is a matrix. Okay, so a matrix is this thing down here, and it's a bunch of numbers put into rows and columns. So it is an array, and it's a rectangular array, and it can have variables or constants. It doesn't have to be numbers. It could be X, Y, and Z. And it has so many rows and so many columns. Okay, so first things first, most people mess up with rows and columns. Is 261 a row or a column? Brady, get a point. So meanwhile, 27912 is a column. Now you actually have to know the difference. It does make a difference when we get to, for instance, multiplication with matrices. You have to know which one's a row and which one's a column. If you get confused about that, because there's so many terms in life you're supposed to know. Think of a column in a building, like Greeks, they had columns. Columns are supposed to help hold up the building. The column helps hold up the building. A row is not helping hold up the building. What's helping hold it up? A column. So that's how I keep track of rows and columns if you get confused on those. Yes, dear?
Another way you could remember that I think is really simple is column has an L, L goes straight up and down.
A column has an L, and L goes straight up and down. That's another good one. So cheat ways to remember row versus column. That's good. Okay, so we have this matrix, and if we read, a matrix is just supposed to organize stuff. So each spot in a matrix has a purpose, and it represents something. And you're like, that's nice. So if we have a lot of data, a whole lot, and we're not wanting to list it all out, we might store it in a matrix. So my best real-life example, because it relates directly to me, is with Netflix. I stinking love Netflix. I don't really know why we pay for cable, something about ESPN, whatever. So I could live my life with just Netflix. I love it. I got really sad 2 days ago because I finished the show. I got to the last episode. And I was brokenhearted. And then I looked at my recommendations to pick my next show because it recommended, it was like, based off this, there's a 98% chance you will like this. So I started a new show, and guess what? I already love it. So how did Netflix know, like a 98% match, that I was going to like this next show? Or like it says, there's like an 80% chance I'm going to want to watch this movie. Like, I don't, so when it makes those recommendations based off what you've been watching, it's using matrices. So no, there's no Netflix guy literally staring at Xavier like, oh, did he laugh at that show? He should watch this. No one's staring at you. No one's even noticing you. Seriously, it's an algorithm. They're using math to figure out your recommendations. So they're using matrices. It's a little more complicated than what you and I are going to use in matrices. But they're using matrices in a little more complicated way to figure out what to recommend so they know what I like. So that way I'll keep watching Netflix all the time, which is what happens. So here we are. So Netflix uses matrices. There are many other real-world examples of large storage systems using a matrix. So, for instance, when I get on my social media, Instagram, whatever, there are eventually ads, and normally these ads are stuff that I like clothes. It's never like hunting stuff. That's my husband. Like, it's normally stuff I like, purses, clothes, shoes. How does it know that? They're using matrices. They aren't creeping on what websites you've been to in the past. But still, they're using matrices to make sure that they recommend stuff that I like to me, whereas, like, Xavier might not be interested in the cute puppy pictures, so he might not get the cute puppy links that I get. Okay, yes, dear?
What's your favorite show, Miss Thompson?
I have so many favorites.
What are your favorite shows?
I really love The Office, and then Gilmore Girls,
Gilmore Girls is so good.
and then, and I love Friends. I tend to watch Friends, The Office, or Gilmore Girls when I'm grading papers because I've seen it so much I don't actually have to stare at the TV. I can just grade your paper while I watch it. But so I finished The Office, and then I love The Secretary, so I watched Unbreakable Kimmy Schmidt. And then that's what I just finished, and I was really sad, yeah, because there's not a new episode coming out till April. This is why I don't watch current TV.
I love Kimmy.
So I've started watching something else, and it's just as stupid but still funny. I just want to laugh. I just want a stupid laugh. Okay, I got distracted. It happens to the best of us. Let me get back focused. That way you can get to your test. Okay, so we're focusing and we got this. With a matrix, we can store lots of stuff, which doesn't really seem useful to us because we're not working for Netflix, but we are trying to figure out a way to make math easier and to solve equations faster. And that's what we're about to learn matrices can do for us. So we have to know what a row and a column is. We also have to know that an element inside, a spot inside, is called an element. For instance, that 1 is an element. It's representing a specific spot. We'll come back to that in a second. And then more importantly, not only do we have to know what an element is, we need to know the dimensions of a matrix. So the dimensions are the size. So if Sarah's talking to someone about a matrix, she's not just going to say 261, 715, 930. Like, they're going to look at her like she's crazy. Instead, what she'll say is, I'm dealing with a 3x4 matrix, a 4x3, a 2x2. And what that represents is the number of rows and the number of columns. And yes, it does matter the order you go in. So a 4x3 is not the same as a 3x4. A 4x3 has 4 rows, 3 columns, whereas a 3x4 has 3 rows, 4 columns. So it does matter the order you say it in. So in the matrix we were looking at above, the top example A, it has how many rows? 4 rows, how many columns? So it's a 4x3, and table 3 can have a point. Okay, so literally our first learning target is as easy as it gets, and we're going to go do the next 6, and I'm going to give each group a turn to go at one of the next 6. But before we do that, something else, I could talk about matrices all day. They're just so cool. Something else really cool about matrices is that, so all the problems we've been doing in math class have been lowercase variables. We're always doing a lowercase x, a lowercase y, lowercase z. We're lowercase people. The only exception to that is matrices. They get to be the capital letters. So if you see a capital letter in a math problem, it's supposed to represent a matrix. Now, that's not going to come up today or tomorrow with us, but potentially on the ACT, you could see it, and you're just supposed to know capital letter means matrix. Okay. Let's go to the bottom 6, so number 10. Table 1, I'm going to let you try that one if you'd like. How many rows, how many columns? How many rows, how many columns? There's 2 rows and how many columns?
No, 3 columns, 2 rows.
So 2x3. Perfect, get a point. Table 2, number 11. How many rows, how many columns? How many rows?
3.
Look at it.
No, 3.
There are 3 rows, 1 column, so it's a 3x1. Table 3, then number 12. 4 rows, how many columns?
3.
So 4x3. And you get a point. Yes, Xavier?
Quick question. I feel like this is stupid to ask.
No.
Will you ever end up in a situation where you have like 1 row and 1 column?
Yes, a 1x1 matrix, which is literally just one number.
Okay.
And sadly, you can think of a matrix like that, but I get that's kind of silly because you're like, it's just one number. If we're storing stuff, why would we only put one number in it? Like, I get that seems dumb. But again, we've got to handle the baby problems before we go crazy with like a 5x10. Okay, so I got count. Table 4, would you like number 13? And you get a point for that. Table 5, would you like number 14? And it's correct, and you can have a point for that. Table 6, would you like number 15? So it's a 3x2, and you can get a point for that. So these are really easy, but again, if you say 3x2, that's different from a 2x3. So you can get counted off for that. Make sure you're doing rows by columns. The only other thing I want to say before we move on, and again, it's just because I just love matrices so much, I got to tell you all the things. Our favorite kinds of matrices are like number 13. When it's the same number of rows and columns, they have a special name. They're called a square matrix because they make a square. Well, it's a 3x3, so technically, theoretically, it's a square. Should they have spaced it better so it looks more square-like? Yes. But so if they have the same rows and columns, it's called a square matrix. And eventually, when we get to do something cooler than just adding, subtracting, and multiplying, we're going to eventually, next week, going to get to something called an inverse, and it has to be square to have an inverse. Like, we're going to love us some square matrices. They're the favorites. It is. Okay. The only thing semi-complicated with matrices is multiplying, and literally, if you'll pay attention the day we do it, it's really not hard either. Like, I love matrices. I don't have enough nice things to say about them. They are the best. Let's go to 16 through 19. Yes, dear.
Okay, you you say they're easy,
No, they're like birds in the sun's out. They are easy. So true. So our second learning target is about solving equations involving matrices. So it was taking you and me like 10 minutes to do one problem before. And matrices are going to turn solving into X, Y, and Z into seconds. And literally the reason I'm saying matrices are easy is because math works the way you want it to. So you would say 2x is the first entry, 5 is the first entry, so 2x equals 5, and you'd be correct. Again, you would say 2x goes with 5 because they're both in the first spots, and you're correct. You would say 3, well, he's in the middle, so he goes with 3y. Yeah, that's right too. So matrices are awesome because everything works the way you think it should. 3z equals 9? Yeah, duh. And so we could literally solve for each of those variables. So 2x equals 5, x equals 5 over 2, 3 equals 3y for the middle, so y equals 1. The middle, I did first guy equal to first guy, 2x equals 5, and I solved for x. I did 3 equals 3y, I solved for y. And now, are you not surprised? I'm going to do 3z equals 9 and solve for z.
Oh, that's okay. Wow.
So suddenly, it took us, 30 seconds? And we've solved for x, y, and z.
That is so much easier.
It's so much faster.
That's like, why did I even do that?
I don't know. So what's crazy, or what someone said last period, they weren't happy. They were like, we got an x number, and we got y equals this number, and z equals this number. Miss Compton, I thought this had to do with matrices, and it does. So if you want to plug these numbers back in the matrix, you can to check yourself. If you plug in 5 halves into that first entry, you're still going to get 5 equals 5. If you plug in 1 into there, 3 times 1 is 3, 3 equals 3. If you plug in z is 3, 3 times 3 is 9, 9 equals 9. You can still check yourself and plug everything in to make sure you're right. But literally, those are still our answers. We still want an x, y, and a z for that problem. Okay, on number 17, I want to go straight to the answer. X equals what number? Eric can get a point.
Oh, yeah, Eric.
4x equals 12, so x equals 3. Although if he makes that weird noise again, I'm taking a point back. Okay, what does y equal? Perfect. So again, I'm going to do 3y equals negative 1. So y equals negative 1/3. Grady, your group can get a point. And that's why I say matrices are easy, because everything you want to happen just seems to work out just so perfectly. Okay, let's go to number 18. So we really are going to set the top equal to each other. I know they both have x's. It's okay. Set up the equation, solve for x, tell me the number. Say it again. 18. Actually handle it. So set 4x equal to 15 plus x and solve. What does x equal?
5.
Yes. So I seriously am going to do 4x equals 15 plus x. I subtract x, so I have 3x equals 15, so x equals 5. But again, if Sarah can do this in her head, she doesn't have to show me all the work. And she might could have done that one in her head, because 4 times 5 is 20, 15 plus 5 is 20. Maybe she was going to guess 5 anyway. Y is what, dear? It is, and you can have a point. Okay, so with the bottom term, we have 5 equals 2y minus 1. So 6 equals 2y, so 3 equals y. Are there any questions about number 18? Why does 19 look harder? It's not harder, but why does it look harder? Yeah, because it's that 2 by 2, and so far we've only been dealing with the one column or just the one row. It's not been with 2. Now we've got 2 rows and 2 columns. But still, yes, Travis, you're going to know all the things. You want me to give you the points for them? Tell me x again. X equals 3, and then y equals what? And z equals? Okay. 5 get 2 points, 3 get 1 point. So we seriously do 4x minus 3 equal to 9. Top entry, top entry. So 4x equals 12, So x equals 3. He's correct about that. And then we go to that second entry. Table 1, you're about to lose a point. 3y equals negative 15. So y equals negative 5. Why do I not have to do anything on the bottom row of the first entry?
Because 7 and 7 are the same number.
Yeah, we're not having to solve for any variables. So 7 equals 7, and there's nothing to do with that. But we still have to do the last entry. 13 equal to 2z plus 1. So 12 equals 2z. So z equals 6. So now, suddenly, we're solving equations for 3 different variables, and we still do it in less than 30 seconds. Are there any questions on number 19? Okay, then there's one thing I've forgotten to say up near the top, so let's go back to the top and talk about an element. So, on the ACT, there might be a problem like this where you have to solve. But I really think for the dimensions ones, they would make it a little more complicated because, let's face it, just saying 4 by 3, now the answer choices are 4 by 3, 3 by 4. It's not a difficult enough question. This is what I think they would do instead. I think they would say 3 is in, so looking at our top big example again, I'm back to this matrix. 3 is in what position? Now what's cool with a matrix is not only is like first row, first column, but each entry can be represented with like an XY coordinate. So 2 is in the first row, first column, so it's 1, 1. 7, second row, so it's 2, comma, 1, because it's second row, first column, so 2, comma, 1. So 3 is third row, second column, so 3, comma, 2. Yes, dear. Yes. They are. So again, if you're trying to figure out exactly what spot he's in, he's on the third row, the second column, so 3, comma, 2. And while we're not going to ask questions like this in this class, or at least I haven't seen it yet in my notes, I think the ACT would ask it like that, because that's a little harder than saying the dimensions of the matrix are 4 by 3. Okay, flip to the next page, please. Tomorrow, because I know you need time to finish your test. Tomorrow, I'm going to go over how to add, subtract, and how to do like 7, 8, 9, 10, where you literally just, so A plus B is the A matrix plus the B matrix. Life is going to be coming up daisy. It works exactly like you think it should. For instance, on number 3, I'm literally going to add 16 plus negative 4, the top entry with the top entry. It's going to work out just like you think it should. But we will deal with that beast tomorrow. Flip to the next page. Also tomorrow, you have to have done, or you're going to have time during class to do this page. So if you were already done with your test, you can go ahead and get a head start on this page. When I come back on Thursday, I'm going to look at everybody's notes and see, did Xavier do the notes? Did Xavier do this worksheet? He's going to get points for that. He's going to make sure it's all done. There are 2 problems on the worksheet that are a little more difficult than the other problems. Can you find them?
14.
It is actually really close to the end.
14.
14? No, 14's okay.
18.
No, 18.
I should just tell you, shouldn't I? 19 and 20. So you might want to put a circle by. I would like for you to try them, but it's okay if you don't succeed. Here's why. So it's got different variables. I know, and then all my joy. I've got to get a little joy somewhere. So, but you just took a test on something called substitution. So on number 20, you've got x equals 4y. Okay, then everywhere in your second equation you see an x, put 4y. So I'm going to say the word skip, but you don't have to, because really, I'm going to put the word skip. I'm going to put sub for substitution. It's not going to break my heart if Xavier skipped these 2. I will go over again on Thursday. But Xavier is brave and he is smart, and this worksheet is easy. It's just got to use substitution. He is smart. He just has to use substitution. Okay, are there any questions about these? Again, when I come back Thursday, did Xavier do the notes? Does he have this worksheet? If not, we got some problems. I'd be mad. Okay, I got on to you. I didn't get on to you. I did. Y'all lost a point this past time you had a sub. You do not want to lose a point.